the ring Z root over minus 11 is a Euclidean domain, a principal ideal domain but not Euclidean domain, or unique factorization domain but not a principal ideal domain, not unique factorization domain. So friends, the problem is Z root over id a plus b root over d is a ring. So friends, before you have to learn whatever you have to learn Euclidean domain, principal ideal domain, everything. You will see my video where I discuss what is Euclidean domain, what is unique factorization domain. So friends, I will not discuss now. So Z root over minus 11 can be written this way, friends: a plus I root 11 b, where a comma b belongs to z, where a comma b belongs to z. So z root over minus 11 is UFD or not, that I have to check. So friends, you will see that 15 is non-zero non-unit element. 15 is non-zero non-unit element, and because 15 belongs to z plus root over minus 11, as 15 plus root minus I11 into 0. This form I can write. So 15 belongs to z root over minus 11, and 1 by 15 does not belongs to z root over minus 11. So now 15 can be written this way: 3 into 5 is equal to 15. So it can be written 2 plus root over minus 11 into 2 minus root over minus 11 equals to 15. So 3 does not associate 2 plus minus 11 and or 2 minus root over minus 11. So friends, it is easily say that it is not. So friends, next problem is GATE 2008. Let R be a principal ideal domain, a comma b any two non-unit, must noted, non-unit elements of R, then the ideal generated by a and b is also generated by a plus b, a b, gcd of a b, LCM of a comma. So friends, principal ideal domain is given. Principal ideal domain is given. What is principal ideal, friends? Let definition of principal ideal. Let R be a ring, R be a ring, an ideal of R, generated by a singleton set singleton set is called a principal ideal let S equals to A and A belongs to capital R and A be the ideal generated A be generated by S is the ideal A is generated by S or A. So A, then A equals to notation this way. So friends, whatever you see, you can, another factor is that, and thus A is the smallest ideal of R. Ideal of R containing A. So friends, this is the definition of the principal ideal. So we can give also example theory. This is, however, this is not theory class, but I also mention the theory because this question answer is based on theory. Example is R means -3, -2, -1, 0. This is a ring, and A equals to 4R. So this value is -12, -8, -4, 0, 0 up to 4, up to this is. So friends, A equals to 4R. So S can be denoted is this way, 4. S can be denoted 4. 4 is the generated, S is generated by 4. And what is the rule? Rule is here A belongs to capital A, and where small r belongs to capital R, and here is also an RA also belongs to capital A. So multiplier of A also belongs to this way we can say that A is a principal ideal. So friends, whatever you see that the smallest ideal of R, this is the smallest case is in here. This writing is very important information. Smallest ideal of R. Now in case A plus B is not smallest, AB is not smallest, GCD of A comma B is smallest. So generated will be possible GCD of A comma B. This is the possibility. So, and my answer is option C. Now next friends, next problem is UN be the set of all positive integer less than n and relatively prime to n. Then UN is a group under multiplication modulo n. For n equals to 248, the number of elements in UN. So friends, you need to learn Euler-Totian function. So order of UN equals to phi n. Must remember friends, order of UN equals to phi m. and now u 248 equals to phi 248 equals to phi 2 cube into 31. And now friends, 2 cube, how can I write? 2 cube into 1 minus 1 by 2. Now formula of Euler totient functions, because friends I need to explain this portion, I do not explain this. So you need to know what is Eulerian totient functions. Suppose if n equals to rho to the power a1, rho to the power a2 up to rho to the power an. So friends, it can be rho 1, rho 2, rho 2, rho. So phi n can be written this way: phi rho 1 a1, phi rho 2 a2, phi rho 3 a3 into phi a rho n. So this way it can be written, friends, and after that it can be written this way, friends. It can be written n into 1 by 1 minus rho 1 and 1 minus rho 2, 1 by rho 2, and this way it can be written 1 minus 1 by rho n. So this way it can be written, where rho 1 and rho 2 are distinct. Rho 1 and rho 2 both are, this is the rho n, distinct prime. So this answer should be 2 cube means 8. So this is 1 by 2 and 31 into 1 minus 1 by 31. So whatever I get, friends, I get 2 cube into half into 31 into 30 by 31, and 31 cut. So I get, and also I get this portion 2 square. So 4 into 30 means 120. So my answer is 120. My answer is 120. As n equals to 248, 248 means 248 equals to 8 into 31, because 8 into 8 into 8, 3 into 8 ja 248. So friends, I am trying to solve GATE 2004. The number of 5 zero subgroups is Z20 is 14556. So friends, you will see that this is Z20 20 and 5 zero group 1 plus 5 k, where k belongs to integer by the Silo theorem, and 20 can be written 5 into 4. So it can be written 1 plus 5k into 4. So what is the possibility divisibility? If k equals to 0, then it is possible. So number of 5 zero subgroup of Z20 is 1. Next problem, friends, GATE 2004. Let G and H be two groups. The groups G cross H and H cross G are isomorphic. So friends, G1 cross H1 isomorphic to G2 cross H2. If and only if G1 isomorphic to G2 and H1 isomorphic to H2. This is the formula. So whatever you see that G cross H isomorphic to H cross G. So it is only possible when G equals to isomorphic to H. So only number D is possible. Now we are going to discuss the order of the smallest possible non-trivial group containing element x to the power 7 and y square equals to e, yx into x to the power 4 y is. So friends, this type of problem, you must remember when we get the dihedral group. This group is dihedral group, friends, and order is 14. Order is 14, and you will must remember that smallest possible non-trivial group, smallest. So if not trivial, if it is the trivial group, then possibility trivial group, then it is possibility 1 order of trivial group, but it is non-trivial, so 1 is ultimately rejected. And must remember that dihedral group, smallest non-trivial groups is always 2, because friends, I have already told that order positions of the element when it is the even and odd, then it is very class equations. We know the class equation of dihedral group, and you will see that this is the order of 2. If you can't understand this logic, I think that you will watch my dihedral group. So friends, again this question is coming from silo groups, that the number of 5 zero subgroups of order 45. So order 45 can be written 5 into 9. This is the order of the 5 zero subgroups. So how can I find out that 1 plus 5k divided by 9? If k equals to 1, then it is not divisible. If k equals to 2, it is not divisible. So only possible if k equals to 0, then in 0 is equal to 1. This is the only possible. So order is only 1. The number of 5 zero subgroups is only 1. This is my answer. Next problem, friends, GATE 2012. W is equal to, whatever W is given, W is equal to cos 2 pi by 3 plus I sine 2 pi by 3. I sine 2 pi by 3 and cos 2 pi by 3, m equals to 0 I 0. M equals to 0 I 0 and n equals to omega 0 0 omega square. This is the n, and G equals to Mn. G is generated by Mn, so it is also dihedral group, friends, because dihedral group have two generators, so it has two generators. Means two generator. Now Mn, what is the value of Mn? If I will multiply Mn, then the value is 0 I omega square and I omega comma 0, and also similarly Nm, if we will multiply matrix multiplications method, then whatever I get 0 I omega 0 I omega squared 0. So Mn does not equals to Nm. Mn does not equals to Mn, so it is non-abelian group. So G is non-abelian group. G is non-abelian group. And whatever you see, friends, you see that G by ZG, so non-abelian group, so it is so G by ZG is not G by ZG is non-cyclic. Why, friends? Because we know when it is non-abelian, if G by ZG is cyclic, if G by ZG equals to cyclic, G by ZG equal to cyclic, then must remember, friends, if G by ZG is cyclic, then G is abelian group, but it is G is non-abelian, so Z by ZG is non-cyclic groups. And hence you can see that S3 is possible because S3 is non-cyclic group. So G by ZG isomorphic to S3. So friends, consider S is equal to C x to the power 5 complex polynomial of x to the power 5, and as a subset of T equals to Cx in the ring of the complex polynomial, then S is neither an ideal nor a subring of T. S is an ideal but not subring of T. So friends, I have to judge that which is correct or not. So S is equal to C into mod of x to the power 5. So it is the polynomial of x to the power 5, complex polynomial, complex polynomials of x to the power 5. So whatever I get, so x to the power 5 into x to the power 5 belongs to C x to the power 5, but C x to the power 5, therefore C x to the power 5 is not subring of T. T that equals to Cx. Cx is also Cx is complex polynomial of x. Cx is complex polynomial of x. So how it is not subject? And x to the power 5 into 1 plus x does not belongs to cx to the power 5, and 1 plus x into x to the power 5 does not belongs to c x to the power 5. So it is not ideal. S is not ideal. Ideal of t. Ideal of t. So neither ideal nor a substitute. This number A is correct. Next we will solve GATE 2003. So whatever we see, sigma is equal to 1 comma 1. This value I can write this way: 1 and 2 3 4 2 3 5 sorry 2 3 2 3 5 9. This way it can be written 2 3 5 and 9. You will see that they are returned 2 3 5 9. Okay, and after that it can be written this way: 4 7 and 4 and 7, and also it can be written 6 8. It can be written 6 8. This is the sigma, and tau can be written 1 7 5 9. 1 7 5 9 and 2 8 3 4 and 6. So friends, whatever you see, 1 2 3 4 5, 1 2 3 4 5. So we see that the sigma and tau are in the same conjugacy class. Now the number of abelian groups of order 10 to the power 5. Now I have to find out the number of abelian groups. So the number of abelian groups of order, now the formula, the number, so the number of abelian groups of order P1 a to the power 1 Pn an up to isomorphism is Pa1 Pa2 Pan. So friends, here question is 10 to the power 5. So 10 to the power 5, it can be written this way: 2 to the power 5 into 5 to the power 5. So order of, so what is the order? Order is, number of abelian group is, order is P5 into P5. So number of partition is 7. So 7 cross 7 is equal to 9. So this is my answer, friends. 49 is my answer. Next question. Next question is: M and N be co-prime natural numbers, then the kernel of the ring homomorphism is phi such that Z tends to Zm cross Zn, defined by phi x equals to x bar, comma x bar is, I have to find out. So friends, put in this case m and n are co-prime, so I can take m and n equals to 2 and 3. M and n equals to 2 and 3 because they are co-prime natural number. So mz z2 can be written, just give a counter example friends, 2 4 4 2 4 6 8 6 8 up to infinity, and z3 can be written 3 6 6 3 6, z3 can be written 3 6 9 up to infinity. So this is the z3. So phi 2 automorphism of 2, phi 2 is equal to x bar and x bar. Phi 2 is 0, 1. This is the 0 bar and 1 bar, which is does not equals to 0, and phi 4 equals to 0 bar and 1 bar, that is does not equals to 0 bar and 0 bar. So nz equals to 3z. Nz equals to 3z and mz equals to 2z, which is not kernel. We can't get any kernel. And so friends, we see that mnz is equals to car phi. So my answer is number B. Next question is, let G be a additive groups of integers I and G multiplicative group of fourth root of unity f such that G tends to G dash. Homomorphism mapping given by f and I to the power n. The kernel of f is empty, all singleton subset of A, the power set of A, set A itself. Sorry friends, here I have written wrong options. Option is empty set is empty set for m belongs to I. So okay, no problem. Option is not a matter. I have to check that where kernel is n. So f such the G tends to G dash. So whatever we get G dash is the fg equals to G dash, and unit of the KRF means, so fn, now fg is equal to G dash, and fn, whatever you see, fn is equal to I to the power n, and KRF is equal to f belongs to G such that fx equals to 1, because this is the identity element. So whatever we get I to the power n equals to 1. So it is 4m such that m belongs to I. This is my answer.